Hi everyone, so this is me talking through the answers to your last worksheet. Now I'm hoping you still found this worksheet fairly easy, but if you didn't, I will talk you through my mindset about how I came up with the answers. So for each of the circuits, my biggest tip is to write down whether they are series or parallel. Then have a look at what you are looking at. Are you looking at current or are you looking at potential difference? Go find your rule for series current or parallel potential difference, and that will help you answer the question. So I'm hoping you've got those rules memorised because they are really, really useful. So let's have a look at number one. Firstly, this is a series circuit, and I know that because everything is next to each other. Yes, you have voltmeters in parallel, but the actual circuit there is series. We are looking at potential difference. So I'd go away and I'd have a look at my rule for potential difference in a series circuit. Our rule is that the potential difference from the cell or battery is split between the components. Now have a look here. You have 6 volts in this voltmeter, 6 volts in this voltmeter. Now if they have split, they must have come from the cell, and that means the cell must have 12 volts originally. Okay, number 2. As above, so the same circuit, but this time you have 12 volts coming from the cell, 3 volts going to voltmeter resistor 1, 2, whatever, and then how much is left over to go to voltmeter 3 is going to be 9 volts because these two have got to add together to make V1. So same idea, the potential difference from the cell is split between the 2 voltmeters, between the 2 components. Okay, number 3, this is a parallel circuit, and again we are looking at potential difference here. So I'd go away and look at my rule, and my rule says that potential difference in a parallel circuit is the same along every branch of the circuit. Now by that I mean, and I'll use this question as my example, if there is 6 volts across this branch here, then there must be 6 volts across this branch here, and 6 volts across this branch here. So that's kind of answered that question, there's 6 volts across each bit. As above for number 4, 6 volts, again, is the same. So it's got to be 6 volts and 6 volts. Okay, now let's look. We're looking at current this time. And this is, in number, I think that's 5, a series circuit. So if you have current in a series circuit, it is the same the whole way round. So if you have 3 amps here, you must have 3 amps here. Now the theory behind this is that electrons can only go at a certain speed in that loop, and there's nowhere for them to go. So all of those electrons flow at the same speed all the way round. Right, number 6. This is a parallel circuit. Now, in a parallel circuit, you're looking at current again. Our rule is that the current splits between the branches. So what I mean by that is current will come from the cell, and some of it will go down that branch and some of it will split off and go down here. Then it will join up together here and go back to the cell. So if you have 2 amps going down this branch and 2 amps going down this branch, you must have had 4 amps originally coming from the cells. Number 7 is the same idea. Again, these are parallel. In fact, just take it that they're all parallel from now on. So again, our current is splitting. You have 3 amps coming from the cell, 2 amps of which have gone down the first branch. How much is left over? 1 amp to go down there. And then again, it would all join up back here and you'd be back at 3 amps on the other side when they've joined together. Oh, let me just move this out of the way. Okay, number 8. You have 1.8 amps in our parallel circuit coming down from the cell. 0.9 amps has gone along the first branch. How much is left over? 0.9 amps again. Okay, number 9. It's a parallel circuit again, so we know again it splits. However, slightly trickier this time. You have 0.5 amps going down the first branch, you have 1 amp going down the second branch, and you have 0.5 amps going down the third. So hopefully you will see they've all originally come from the cell. So this one up here will be 0.5 plus 1 plus 0.5 gives you 2 amps coming originally from the cell. Then let's look at B. At B, you started with 2, 0.5 of it has gone off up here. So what are you left behind to then split up? 1.5 amps. Okay, number 10, same idea as number 9. Again, it's parallel, we know this. You have 3 amps, 1 amp and 2 amps. So coming from the cell must be 6. That's them, all of them added together. B, where you've taken 3 amps away from it, will be 3 amps again. And over here at C, where they all join up again, it will all be back to 6 amps. All right, hope that made sense for everyone. If you have any extra time, please memorise your rules. You can see how handy they are. Thanks, see you soon.